Section 1.4, Properties of Trigonometric Functions. Now in this lecture, we will learn the domain and range of trigonometric functions, even and odd trigonometric functions, and periodicity of trigonometric functions. Now, before starting, I want to talk about the functions here. So we generally write the functions as f of x, and here x is the input, and this f of x is the output. So the set of inputs, so set of x values is called domain. So these are the inputs, the set of the inputs that is accepted by the f is called domain, and the values, the set of the values of f of x for all x. I mean, for each x we have one value, so all of them will together will be the range of the f, range of the function. So let's remember those. And okay, and we will talk about the trigonometric functions. We have 6 trigonometric values. One of these are like cosine. We were saying theta, and then sine theta, and then tangent theta, and cotangent theta, and secant theta, and cosecant theta. Now we can put here x. You know, these are standing for the angles, right? Now we learned how to find the values of them. So for example, theta, we check the quadrant, theta in quadrant, let's say 2, then we do like the reference angle, alpha reference angle, then we say this cosine cosine of theta is equal to minus, in the second quadrant it will be minus cosine alpha. You know, we are given like, okay, if anything given to us like 300 degrees, so we make the reference angle at 60 degrees, and then you can convert this 300 to 60, and we say it's positive in the fourth quadrant. You know that you know how to do them. So we always reduce the angle to a right triangle. So it's done this way. So for any values, so now we will consider these functions as a function of x. Now our angles will be x. Now we will concentrate on these here, which x values are accepted by cosine. And what can we say about the cosine x, the values of cosine x? Here is all x values or all angles are accepted, or do they give a defined value? For cosine and sine, we didn't notice anything there like undefined, but here, for example, tangent 90 degrees, or tangent, you know, 180 degrees, or you can say tangent 0, no, not tangent 0, but especially tangent 90 and tangent 270 here. We can add like some more on this. I mean, we can also put like tangent 270 plus 185, so it will be something like 450, for example. Now when you try to find them, you will see, you know, you remember how to do it, like, you know, find 90 degrees and, you know, pick a point here, then use the tangent formula. Tangent 90 turns out to be like 1 over 0, so it's undefined. So for some values it's undefined, so you can do the same way, undefined. 450, okay, you go here, 450, it will make again up to here after 360. we'll come to here and we calculate this. Again, we will get 1 over 0, which is undefined. So as you see, for some x values or for some angles, we cannot calculate the value of tangent. So then we say 90 is not, so for example, 90 degrees is not in the domain of tangent for 10x. So what is the situation for all of them? Especially we will pay attention to these 3 of them, because the others are just 1 over of the others, so we'll pay attention to them. Okay, and one important thing here is, okay, 2 important things. I told you the first one. The first one is we will accept all our trigonometric functions as functions here. So 1 cosine x or sine x or the other. So it might be x or theta, whatever. They will be considered functions. These are functions. Now we don't limit ourselves to just specific angles. It can be anything, this x, as long as the trigonometric values can be calculated too. This is very, very important. Now x, so the input angle, the input will be considered as will be taken in radians. So this is very, very important. So we will not talk about tangent 90, but we will talk about tangent pi over 2. So then, we will talk about all in terms of radians. So we will not say cosine 60 degree anymore. We will just say cosine pi over 3. So this is very important. Now, we will do some observations before telling the domain and the range of trigonometric functions. Now, let's start with the cosine and sine. Cosine x and sine x. Now, for x values, okay, this is how we find it. Okay, from the x is given to you, then you find the reference angle, and after the reference angle, you look at the quadrant. Which quadrant is it? And you evaluate the cosine reference angle. You put plus or minus, and it's the same issue here. So is all x values are accepted in all the angles? Yes, indeed. Now you can see it from here, from the unit circle. It's -1. Sorry, this is +1. This is -1. Now, when you take any theta value here, it will be cosine theta and sine theta here. Take the x values like these angles here. So you go from 0 to pi, and pi to 2 pi, and 2 pi to 3 pi, 4 pi. I mean, all of them. So from 0, by using the multiples of pi, you can, if I give you the x value, and you can find its terminal point here or here, then you can use the reference angle. And if you are asking about what about the negative x values, we didn't do the negative values, but it's the same thing. You start from negative values, like I say -100, you come here -100, and you find the reference angle, or you just look at here, or you go to -200, I mean -360, or you go back. For the negative values, you will find the values. Find the angle, corresponding angle, and you will find here the cosine and sine. So for cosine and sine of x, and all x values are okay for them. domain is all real numbers. And all x values are accepted because we can draw all x's as the angles here by, multiple turns, multiple rotations, or the other way for the negative angles. And in the same way, what can you say about the range of cosine x and sine x? Here, look at here. The cosine and sine is taking the values from 1. Okay, it was 1 here, cosine 0 is 1, and sine 0 is 0. And now when it comes to here, 1 will be 0, and the other one will be 1. And here it will be minus 1, 0, and here 0, minus 1. So as you see, the values of cosine theta is between changing between minus 1 and 1. So it means the range of cosine and sine is minus 1 to 1. This is one thing to learn, one thing to see. So this observation and the errors are listed here. Now look at here. Okay, this is telling what I'm telling. So, but here it's bringing everything to reference angle, and the reference angle is about the ratio of the sides of the hypotenuse, and by using this, the adjacent side over hypotenuse, it's less than 1. So it's using this argument here. So instead of the unit circle, it brings back to the ratios, the trigonometric values in the right triangle. This is one way to see it. Now, how about this secant x and cosecant x? They're reciprocals, and what can you say about their domains? Here, obviously, it doesn't accept any x value, making this 0. So, for example, cosine pi over 2, which is 90 degrees, is 0. So, secant 90 pi over 2 is 1 over 0 then. So, it's undefined. So, and how about this cosine 350, 3 pi over 2, which is 270, it's again 0. And when you put here secant, then you will get this 1 over 0 again, it's undefined. As you see, the values that make cosine x equal to 0 are not accepted by secant x. So the domain of secant x is all real numbers except the zeros of cosine x. And in the same argument is working for sine x and cosecant x. So the domain of cosecant x is all real numbers except the zeros of sine x. Okay, what are these zeros? Can we make a list of the numbers that make sine x and cosine x 0? Yes. You will see that list in detail in the table in this next slide. Now, one thing we have to mention here is their ranges here. How about if cosine x is less than 1, bigger than minus 1, and less than 1. So what can you say about 1 over cosine x? So the thing is, it's not easy. We cannot flip and say, hey, it's this. No, this is not true. Okay, why it's not true, I want to tell you. This is a little tricky. And this is a little advanced topic. So if you don't want to spend on it, you can fast forward. And then you can go to the next slide here. The thing is, we have two things. We have two cases here. A cosine might be 0. If it is 0, it's 1 over cosine x will be undefined. So I will not take this one. Or we have this one. Or cosine x is bigger than 0 and less than 1. Now, in this case, I will just say cosine is negative, and I will not take this one, but say cosine x is negative. Okay, because I will not take the 1 over of it. So when you divide both sides with cosine x, you will get 1, but cosine x is negative. So when you divide it by the negative, it will have this one. Then multiply with minus, you will get 1 over cosine x. is bigger than, no, it will change the sign again, so it will be less than -1. And you can do the same thing here. So 1 over cosine x. So now this one, write it. I cannot use it. It's 1 over 0. It will be undefined. So you say cosine x is positive, and you divide both sides with cosine x. So it will be, sorry, it will be 1. Okay, divide by cosine x. You will get cosine x, and you will get this here secant x is bigger than 1 or less than -1. So what does this mean? It's minus infinity to -1 union 1 to infinity. This is a little advanced, so it requires some attention. But if you don't want to spend time on it, so it's okay. You can go forward. You can forward and go to the table of the domains and ranges. Now this is what I wanted to tell you. The range of secant x is this one, and in the same way the range of cosecant is this one. And when it comes to the tangent, the only problem is the values of the zeros of cosine x. So the domain of tangent x, it will be the same as the secant of x, because the secant x also does not want cosine x to be 0. So we exclude the zeros of cosine x for tangent x. Now in the in the next slide, you will see a full open formula, or the sets of domains and ranges. Is this list. Okay, domain and range of trigonometric functions. Cosine theta and sine theta is the easiest ones, and their domain is all real numbers, and their range is -1 to 1. So if someone asks you this, for example, is there any sine theta which is equal to 2? So there is no such theta. No such theta. Why? Because sine theta can be at most 1 and at least -1. Because, yeah, it's the range, and it's coming from the triangle, right triangle, right? It doesn't divide it by hypotenuse, it's always less than 1. Now, tangent theta, the domain of tangent theta is all angles except those. Here, z is standing for all integers. Okay, and now when you put them here, so for each value you put here for k, and there's a big list of numbers. Now, so we are taking them out. So these are the numbers. When you put k's here, these are the numbers we got, and then we remove them from R. So tangent theta domain is this. Domain of tangent theta is this. So here I want to show you the problem. What happens if I got tangent pi over 2? So if you put one of these values, you will get this is undefined. So pi over 2 is 90 degrees, tangent 90 degrees, it's undefined. So for these values, tangent is becoming undefined. So we remove them from the real number. So it becomes the domain. Now, domain of tangent x or theta. And now here, the range. So tangent theta can take any value from -infinity to infinity. And in the same way, the cotangent theta has the problem at these points. So if you calculate them, so it will be cotangent like 0. You can calculate this one like 1 over tangent, or no, let's not do tangent. Or we can do tangent. 1 over tangent 0. So when you put tangent 0, it will be here 1 over 0, which is undefined. So you see cotangent 0 is undefined. So which type of numbers which type of angles are making it undefined? So the integer multiples of pi. So I want to remind you the integers here. Integers are these numbers, all positive and negative numbers. I mean the integers. And for the secant theta, these are making the problem here, like pi over 2 and 3 pi over 2, and this is minus pi over 2. And in the in general form, we can write this one. All thetas are okay, but not this type, like the even odd multiples of pi over 2. Now I want to show you this one here. What if we take one of them here? What happens? Secant pi over 2. What is secant pi over 2? It's 1 over cosine pi over 2. And here cosine pi over 2 is cosine 90 degrees, and cosine 90 degrees is what? 1 over 0. So this is undefined. So it means if you take one of these numbers, so secant give you undefined. So we remove these values from the real line or real numbers. So the domain of secant theta is all real numbers except those. So this notation here is removing this part from the real line. And what about the range? Its range will be from minus infinity to minus 1, and union from 1 to infinity. Okay, and cosecant theta is 1 over sine theta. And what happens, one of these, I mean, if I take, for example, 0, what happens? It's 1 over sine 0 is 1 over 0, right? So this makes undefined. So these are the values making it undefined. So we remove them from the real line or the real number. So it gives you the domain of cosecant theta. And in the same way as secant theta, it has this range. The range is minus infinity to minus 1 union 1 to infinity. Okay, we can give you this short table about the graphs. About the domain and the range of the trigonometric functions. So you see them now in set builder notation here. Here K means you're taking K from this set here. The Z is what? You're taking all negative and positive numbers here. All integers. So Z, so you put them here, one by one, and then you find all the numbers that will be removed from the R. But the good thing about cosine and sine, they accept any angle, and their values will be always between minus 1 and 1. Now, what kind of questions can we expect? Can we answer with these with this knowledge? Okay, determine the domain of the following functions. Now let's concentrate here. We want to find the domain. Domain means the set of the x's. Now, in doing that, you will concentrate only the inside. Where is x? Where do you see x? It's here. So you have to concentrate on the inside of tangent. So there are some numbers like outside here too. No, it doesn't affect the inputs. The inputs has to be chosen according to tangent. So tangent accepts what numbers? So you look at the domain of tangent here. Okay, I will show you a systematic way of doing this. So you can say this is theta here, and then you will say, hey, theta can be anything but not those numbers here. So it cannot be those numbers. Then what is theta? You write x plus pi over 3 cannot be equal to pi over 2 plus k pi. And then, solving this for x is the same as, an equality or equation. So x is not equal to send pi over 3 to the other side. You will get this one. And then when you do this one, it will be pi over 6. Okay, I want to show you how it is done then, because in the slide you will see the same steps as I did. So, but the important thing here is you have to pay attention to the inside here, okay? So where do you see x? It's inside the function. So you have to pay attention to the function and this terms. Now, look at here. So you check the domain of tangent first, or this is the function here. We use this. And tangent theta is defined for theta which are not equal to this. And k is, k is the list of numbers. K is in integers. Now, you know this from the domain, from the table, and then you set theta equal to x plus pi over 3. This is, inside tangent, we see x plus pi over 3. So you see that here we write theta for it, and then you solve it as I did. You solve it like you said, it's not equal to. So then we conclude this is not equal to x, not equal to, and then this becomes like pi over 6 plus k pi. So you write the domain this way: x can be anything but not this one. So it will be pi over 6 plus k pi. And where k is z, so k means z is like k can be anything. -2, -1, 0. I'm including all of them, all the integers. And we have the same thing here. Okay, let's look at here at the second problem. In the second problem, you have to, for the inputs for the domain, you have to concentrate on the inside of the function here. Where's x? It's here, 2x. Okay, good. Now, which function is it? Cosecant function. So cosecant function. How about the others, 5 and 4? They do not affect the domain. So they're outside the function. So look at cosecant here. Cosecant domain is this. So theta, the term inside the cosecant theta, should not be equal to k pi. So this here, this term theta is now 2x. So you have to pay attention to here. Now let's look at this one. Okay, this is how it goes. You know the rest. So first, check the domain for cosecant theta. This is the main function here, like the x is inside that function. So then from here, we wrote this one. Theta should not be equal to k pi. Look at here, it's here. And then inside cosecant 2x, inside the cosecant we have 2x. So we set theta is equal to 2x. Then we write this not equality. So I will call this one not equality. So we have two things like theta is not k pi and theta is equal to 2x. And I put this one here. So you got 2x is not equal to k pi. Then I solve it. So how do you solve such a thing? You just solve it as it is, as if it is like an equation. So x equal to not k pi, you divide both sides with 2, and then you will get this. Then x is not, x is in real numbers, but x cannot be k times pi over 2, where k is integer. So it means like pi over 2 is 90 degrees, so you can say x can be anything but not the multiples of pi over 2. Let's do this try and check exercises here. Okay, please stop the video and try to solve it yourself. It's almost the same thing you will do. You can start from secant. Okay, what's the domain of secant? Secant of x, or secant theta, let's say. Okay, let's use theta. Okay, now this will be equal to all theta in R, such that theta will not be equal to what? Okay, now I don't remember. I have to look at the table. But can I find it somehow? Yes, I can do some tries. Okay, secant means like cosine, theta. What makes it undefined? So if it is 0, then this is undefined, right? So it makes it undefined if this happens. So what makes it 0? So cosine 90 degrees, as far as I know, it's 0. Cosine 270 is 0. And I remember, so when you look at them, these are the odd powers, like 1 times 90 and 3 times 90. So it becomes like the odd powers of 90. So how can I write them? Like I can say k pi plus pi over 2. So when you put 0, you got 90. And when you get k equal to 1, then you will get 180 plus 90, so you will get 270. So I will say these are the zeros of cosine theta, and so theta cannot be k pi plus pi over 2, k, where k is integers. So secant theta, the domain of secant theta is this, and now it means here, well, you can write this one. So now, what is theta here? Theta is this one here, set theta equal to 2x, and write the same thing, 2x equal to, not equal to, k pi over 2 plus pi over 2. And how do you solve this one? You divide both sides with 2, so it will be x will not be equal to k pi over 2 plus pi over 2 over 2, which is k pi over 4 plus pi over 4. And now, okay, I will erase this one. So you say x should be, okay, x should not be, let's say x should not be k pi over 4 plus pi over 4, and then where k is in integers. So you can say the domain of secant 3 secant 2x is equal to all real numbers except those. X can be anything but not these numbers. This is how to say it mathematically. X can be anything but not this type numbers. Okay, we got the domain. So let's do the other. So again, you have to pay attention to which function. Now you have to pay attention to cotangent here. Cotangent. Now, and okay, let's start with the cotangent. And okay, then I will come. Okay, I will write. Okay, let's start. Domain of cotangent theta. I have to. Okay, the x is here inside, so you don't pay attention to 5. Just look at cotangent theta. What makes cotangent theta undefined? So it will be, if I think it's like 1 over tangent, then the tangent theta, cotangent theta. So tangent theta, if it is 0, then this will be a problem. So when it is 0, theta 0, tangent 0, 0, and tangent pi, yes, it's 0. So it should be k pi. But here, if you don't remember, if you don't know how to do it, yeah, please look at the table. Okay, please look at the table. If you don't know how to do it, please look at the table. Okay, guys, I don't want to erase this one. I mean, if I go back to remove this example, I will lose what I wrote, all my recording, so I will keep this here. Okay, don't pay attention to here, this one. Now, we know cotangent theta is this one. Now, what is theta here? Set theta is equal to 4x plus pi over 3. And now we know theta cannot be k pi. So we say 4x plus pi over 3 cannot be k pi. And here k is, of course, representing all the numbers from the integer set. And then you send this one to the other side for x equal to k pi minus pi over 3. I mean, you solve it as it is like an equality here. And then you divide both sides with 4. So you end up with x equal to, not equal to, sorry, k pi over 4 minus, okay, I will separate them and I will do pi over 12 here. You can do this. I mean, you can separate them right this way. And then it means the domain of gx is, okay, I'll write the whole thing here, is all x values except those. And this k is standing for all z. So if I ask you to list all of them, you have to put like 0, minus 1, minus 2, 2. I mean, for each value of k, you will have some value there. Okay, now it gives you, so here is the answer then. Domain of gx is this one. You can also read this here. I mean, I'm not sure if we have a new question here. Sorry, I have to erase this one because I might have something to be, read. Okay, we are done with this. Now, look at the range question here. The range question is, now it's asking the range. Now it says, determine the range of the following files. So it's asking the range. So we pay attention to here the cosine. Okay, so the range of, range of f and range of g. So here you have to pay attention to cosine and sine here. And you have to pay attention to this part now because it's not asking about the input. So we don't care about the input now. Don't care about the input. So if someone asks us about the input, it will be about the domain. So the only thing is the value of the function. Now in this type of question, in the range question, what we can do here is this. For x, we have to find a boundary. I mean, we have to limit this function between two numbers. So let's remember this. What is the range of cosine x or cosine theta? Sine theta is between -1 and 1. So we will start from here. So this is the range of cosine, right? -1 to 1. So we will start from this fact. Now, the range of cosine theta is -1, 1. So it means this. You will see it now. So no matter what x is, here the input, it's cosine 2x is between -1 and 1. And then you will try to get, okay, from here, what we do here is try to get, we will do some manipulation and we will try to get to -3 times cosine 2x. So it will be bigger than or less than some number. So then we will tell the range. Now look at here. So how can we do it? We have to multiply both sides with -3 to get -3 cosine 2x here. And when you multiply with a negative number, as you see, we multiply with -3, we get 3, but here, see, the direction of the inequality changes. Now we got this one. This is about solving the inequalities, or not solving, but let's say the manipulations on, the algebraic properties of inequalities. It's about the algebraic properties. Now we have our function, so f of x is now this, and it's between -3 and 3, and we can directly say the range here is, the range of f is -3 to 3. And for the other function, this one here for gx, we will start with sine, and this, treat them as like theta. Is not very important, just we will try to do the same thing for these. Now for g of x, we know sine theta, the range of sine theta is between -1 and 1, and it means no matter what the inside, it will be between -1 and 1. So how can I get to, okay, the question here is, how can I get to, okay, from sine 2x minus pi less than 1 minus bigger than -1, how can I get to 4 plus 5 times sine 2x minus pi? So one thing is you can multiply with 5, so you multiply with 5, so this, it gives you this one. Then you can add 4 to both sides, I mean all sides, and it will give you -1 on one side and 9 on the other side. So it will give you, adding 4 to each term yields 9, add 4, add 4, and then add 4 here. You'll get this one. And now you have the gx is less than 90 and bigger than -1. So you can say the range of g is -1 to 9. Okay, let's look at this try and check problem. Now, secant 2x, and there's a cosine. Okay, please do it yourself. This one I will just write the answer here. It has to be between 7. Okay, it has to be between -2, 1, 3, and 7. Okay, it has to be between 3 and 7. The range of gx. This is the answer here. But for this one, okay, secant. Okay, in the secant, this is a little tricky. In the secant, we have this secant theta is, the range of secant theta. When you look at the table, you will see range of secant theta is -1 to -1, minus infinity to -1 union 1 to infinity. So if you try to write it in terms of the inequality here, you can say secant 2x is less than or equal to -1, or, okay, I hope you remember or thing, that was a union, so we go back to or. Secant 2x is bigger than or equal to 1. Now when you multiply this 3, this one with 3, so you will get secant, the inside 2x is not important for us, I told you. So you got this function f, it's less than -3, or do the same thing, so multiply with 3, secant 2x, it will be bigger than 3, and you will get f is bigger than 3 or equal to 3. And then at the end, what does it tell us? It tells us the domain, the range of this range of f is -infinity to -3 union 3 to infinity. You can do this with or, this union means or, so you can write it as an interval this way. And now we will see a property of another property of trigonometric functions, and we will see all trigonometric functions are either even or odd. Before doing this, okay, I want you to look at here the unit circle, the property of unit circle. You know, if it is theta here, then this the corresponding point here on the unit circle has to be cosine theta and sine theta. This is the rule. And here, if you try to make a negative angle, which means it's negative theta, we will start from here, we will go this way, and it will be negative theta. Now, when you look at here, geometrically, they're coming to the same thing. So here, the only difference is, as you see here, this will be cosine theta, and it will be here. Sorry, this is sine theta. The height will be a negative height, so it will be negative sine theta. And cosine theta is same here, right? The cosine theta is corresponding to here. So the this point here will correspond to it will have the x component as cosine theta and y component as negative sine theta. So what does this mean? Okay, from here you can say cosine negative theta is equal to, okay, this has to be equal to cosine negative theta according to our rule, and it has to be cosine negative theta according to our rule. You know, the rule is whatever you have as theta, I mean the angle, you will put them inside cosine and sine. It will give you the x component and y component, and here it will give you cosine negative theta is equal to cosine theta here, okay, and this will be sine negative theta will be equal to minus sine theta. And yes, this is giving us some relation. If we have a negative number or negative angle, so it gives some idea about what to do. Or if you don't want to use this one, if you want to use the reference angle, you can do the same thing, like minus theta, it will come back to here. So what is the reference angle for this? Okay, this is the initial side, this is the x-axis, and this is the terminal side of negative theta. And then this angle here will be the reference angle. This theta is the reference angle of minus theta. So then you can write here cosine minus theta is equal to, here cosine is positive here, LSTC. So we will say cosine minus theta is equal to cosine theta, because the reference angle of minus theta is theta. So we can have this one, and in the same way you can get this one because sine is negative there. Also you can use the reference angle. Anyway, by using the unit circle or using the others, I mean using the reference angle, you come to the same decision. And this fact is given as this. Here sine x is an odd function, so and in the same way tangent x and cosecant x and cotangent x, they're all odd functions. So odd functions, you know, odd function means f is odd if f of minus x is equal to minus f of x. So f is odd means this. So the odd functions, that the four trigonometric functions are odd. So sine x, so sine minus x, you can take it minus as out, minus out, and then tangent minus x is minus tangent x, and this cosecant negative x is equal to negative cosecant x, and cotangent negative x is equal to negative cotangent x. The good property is this, like if someone wants to calculate what is cosine 90 degrees, so sorry, this is sine 90 degrees, so one can say it's negative sine 90 degrees, and sine 90 degrees is what? It's minus 1, for example. So you can directly go back to the positive angles and can tell the value of the trigonometric value. Now, cosine, about the cosine, we have this property. Cosine x is, and its reciprocal, the secant x is 1 over cosine x. So cosine x and 1 over cosine x, they're or secant x, they're even trigonometric functions. So cosine minus x is equal to cosine x, and secant negative x is equal to secant x. Now, sine x, its reciprocal is, okay, remember this is 1 over sine x. And I want to remind you this tangent x, its reciprocal is cotangent x. So sine x and its reciprocal and tangent x and its reciprocal, they're odd trigonometric functions. And cosine x and its reciprocal secant x is even trigonometric functions. So let's try to find the exact value of these trigonometric expressions. Cosine negative pi over 3. Cosine keeps, okay, we can erase negative from here, so its cosine is even, so we can remove this minus and you can write cosine pi over 3. And pi over 3 is 60 degrees and cosine 60 is 1 over 2. And if you don't remember this, I mean, I would suggest you do this 30-60 triangle and write here 1, 2, square 3. Here, be careful. Sometimes the people confuse these numbers. Here, the biggest side has the biggest number, and the second one, the middle number, 60 degree, has square root 3. It's about 1.7, and the smallest angle has the smallest number. You know, smaller side, smaller angle. So angle, the size of the angle and the size of the side is kind of not proportional, but in terms of size, smaller gets smaller, smaller angle gets smaller size, smaller side, and the bigger angle gets the bigger side. And how about the tangent? We know tangent is an odd function, so we can take this minus out, and then it will be minus tangent pi over 4, and the pi over 4 is 45 degrees, and tangent 45 degrees. If you don't know it, you can do this 1, 1, square 2 triangle, and it will be tangent is opposite divided by adjacent, so it will be 1, so you got minus 1. Now, another type of question is determining whether these functions are odd and even. So I want to remind you this one first. Here, okay, how to check the odd and even function. You write f of x, you write f of minus x, and you write minus f of x. Then if these are same, we say f is even. Now if these two are same, then we say f is odd. Now if these two, the first two are not same and the second two are not same, so in this case we say f is neither of them or neither of them. So we will do this. We will use this fact when showing them their when determining their odd or even. Okay, let's do this exercise or do this example. Now we want to determine whether f1 is odd or even. Now first we write f of x. You know, we do it this way: f of x, and then write f of minus x, and then check. If they're same, okay, no need to look at the other one. But if they're not same, so just look at the other one, minus f of x. Okay, we will do all of them. Now f of minus x is, okay, this one here. Be careful, this cosine minus x is cosine x because cosine is odd, sorry, even. And now, are they same? Okay, these are same, as you see. Now you don't have to do this one because they are same here, the first two. But anyway, I did all of them. I mean, I wanted you to see. Okay, I want you to see these two are same, so it's even. So these two are not same. This is not okay. F is not odd. Here you have to be careful here. Minus, so I'm making minus 2 minus cosine x, so I'm putting them in parentheses. So since you have even, no need to do this one because there's no even odd function at the same time. So f of x is this, and now you put minus x for x, so that will be sine negative 3x, and sine is odd, so we will have the negative out, so negative sine 3x, and you see they're not same. But minus f of 2x, which is minus 3x, so as you see they're same, so you will see they're same. So this is not even, but it's odd. And let's look at these two functions here. This is the product of two functions. The f of minus x, let's write it, and let's replace x with minus x. Now, as you see here, now this one is, cosine is an even function, so you can remove this negative. But tangent here, tangent minus pi x, so tangent is an odd function, so you will take this negative out. So you have this one. So when you look at these two, they're not same. But when you look at this negative f sub 3x, so you get minus 2 tangent pi x times cosine x. So as you see, these two are same. And in this case, we say it's odd, not even. Now, when it comes to the f sub 4, first we write f of x, okay, then f of minus x, so you just replace x by minus x in the formula, so you have secant minus x, and it's 1 plus secant sine squared minus x. So secant x is like 1 over cosine x, so cosine is even, so secant is even, so then you can remove this minus, and you have this one. Now sine squared x, okay, I want to show you the sine squared minus x. This squared means sine minus x times sine minus x, so it's taking the square of sine minus x. So this is minus sine x, sine is odd, then we have minus sine x, so minus minus, it will be plus, so we will end up with sine squared of x. So we will end up with this. And this is f sub 4, and minus f sub 4x is minus secant x over 1 plus sine squared. Now, when we look at these, okay, let's compare them. F sub 4, are they same? So they're same indeed. So you don't have to do the other one. I mean, you don't have to, but anyway, I included it in my calculations. So it's even, so no need to look at this one indeed. Now let's look at the last one, cosine x plus sine x, so you exchange x with negative x, and just do the same thing here, and cosine minus x, cosine is even, so you can remove this minus, and then minus sine is odd, so you can take it out, and it will be minus sine x plus cosine x, and you check them. They're not the same, so this is not even. And in the same way, we look at minus f of f sub 5x. And when you multiply with minus both sides, then you will get minus sine x and minus cosine x. And you see they are not the same either. So f is not even, and from these two, they're not even, and they are not odd. So the answer is neither even or nor odd. Now, let's talk about the periodicity of a trigonometric function. Now, what does periodicity? When we say something is periodic, it means it repeats itself, time to time. Like after some time, it will come back again. Like what is periodic? The years are periodic. The solar years are periodic. So it means like winter starts, and like about 365 days later we get winter. With slight differences, but we can call them periodic. Now it repeats. Something periodic means it repeats itself. Now, mathematically talking, a periodic function is said to have a period p if the function repeats itself after p units and does not repeat itself after any unit less than p for all x values. So mathematically, f is periodic with p means the value of the function for x will be same after x plus p or after a multiple of p. So the trigonometric functions are having the same property because of the setting of the Cartesian coordinate system, the angle. So because the angle here, theta, after like 360 degrees, we will come to the same terminal side, and it will give you, if you have the same terminal side with theta, you will get the same trigonometric values as theta. And if you go like theta plus 4 pi, you will end up with the same terminal side. And having the terminal side, same terminal side means having the same trigonometric values. So because of this, we can say these functions are periodic, like the sine x. After 2 pi later, it will have the same value, and the cosine x and cosecant and secant. So basically, sine x and the related function cosecant x and cosine x and its reciprocal, they are all 2 pi. But their period is 2 pi, so it means they repeated themselves in 2 pi. But tangent x and cotangent x is not like that. They're less than pi, so their period is pi, because tangent is positive here and tangent is positive here. So as you see here, when it comes to here, we'll get theta as the reference angle. We will have the reference angle, so we'll get the same values. And in the same way, this tangent is minus here and tangent is minus here. And if we have something here, theta, then we'll get the same thing here, theta. So it's minus again, minus again. So it means if you add pi to an angle, pi later, you will get another angle which has the same terminal side and the same reference angle and with the same sign. So in this case, after each pi, we'll get to the same tangent value. So we tell them this way. So this k means like you can add a few times, like not a few times, every integer powers or every integer multiple, adding every integer multiple of the period will bring the function into the same value as x. So this writing means this. So for any x, for a fixed x, and then x minus 2 pi and x plus 2 pi or x plus 4 pi or x plus 6 pi, they have the same value. And for x, for cosine, we have the same issue because it's 2 pi. The period is 2 pi. For the cosine secant, we have the same, but for the tangent, you have x, pi later, you will get the same thing, and pi later, you will get the same thing, and pi later, you will get the same thing, and pi, if you subtract pi, it's also okay. And we have the same thing here, like cotangent x and pi later, pi before, pi before you can go back. They will have the same value. Okay, let's solve this example. So we will evaluate these terms by using the periodicity of the functions. Now the first thing about the cosine is if you want to use the periodicity of the function, so you have to know the period of cosine. The period of cosine is 2 pi. So what does this mean? This means for any x here, you can add the multiples of 2 pi, it will be same, or you can subtract the multiples of 2 pi, so they're all same. So in this case, you will decide what to do, like subtracting 2 pi or its multiples or adding. Which one is useful, you have to try. Now look at here, cosine 3 pi. What I want to do is I want to bring it to some angle. Okay, I will try to make it like cosine of an angle, which I can deal with. I mean, I can solve this one. So 3 pi is 3 times 180, it will be 540. So I don't want to deal with 540 here. So I want to subtract 2 pi from here. So when I subtract 2 pi, so the value of cosine will be same. So cosine pi will be equal to cosine pi. Cosine pi means cosine 180 degrees. And what is cosine 180 degrees? Okay, for the multiples of 90, it's better you use for cosine and sine especially, it's better to use the unit circle. It's 1 0 here and minus 1, sorry, this is 0 1 and this is 1 0. Okay, minus 1 0. And remember this, it's 180 degrees. So corresponding point is this, and since it's the unit circle, it means cosine 180 is minus 1 and sine 180 is 0. So we have cosine 180 is minus 1. Okay, we can solve the other question also this way. Now, what is the period of sine function? So the period of sine function is the period of sine function is 2 pi. So this means you can add or subtract multiples of 2 pi to this value here, and the value of sine will not change. So how about adding 2 pi? This is something very close to 2, so it will be better to add 2 pi, and then when you do this calculation, you will end up with sine pi over 4, and this is sine 45 degrees, and sine 45 degrees is, if you don't remember, you can make this 1 square 2 triangle. It's 45 degrees here, so it's opposite side divided by the hypotenuse, it will be 1 square 2. Or if you want to rationalize the denominator, you can get this. Also, one can try to use the oddness of sine here. You can take the minus out, and you will try to get the sine value of 7 pi over 4. It's also possible you can use the reference angle for it, but this way it's much easier. It requires the experience, it requires some experience to see which one is better. Now, tangent first, if you want to use this periodicity, you have to know the period of tangent. So the period of tangent x or tangent theta is pi. Okay, the difference between them is like sine and cosine has 2 pi, the period, but here tangent is pi. So what does this mean? This means, okay, I can subtract some multiples of pi, and it will give us the same thing. So the value of tangent can be found by, okay, I will subtract some pi here, okay, but how many pi's it will be good. So for this reason, okay, it's better I write 35 pi over 4 as okay, I can write this one as like 28 pi plus 3 pi over 4, and here this will be 7 pi, and I can make it this one is like 7 pi plus 4 pi, 3 pi over 4. Okay, they are same. And I can remove 7 pi from here because I can, subtract them a multiple of pi, and the value of tangent will be same. So what is tangent 3 pi over 4? This will be, you can calculate this one. This will be tangent 135 degrees, and it will be, okay, it will be second quadrant. Go to the reference angle, that's 45 degrees. It's, okay, tangent, it will be equal to tangent 45, but here the tangent is negative, so we get minus tangent 45 degrees, in which is equal to minus 1 over square root 2. So, sorry, this is minus 1. So if you want to see, you can do this right triangle here, so 45 degrees, 45, and 1 square root 2, and 1 over 1, it will give you 1. So the answer is minus 1. So the answer here is minus 1. Okay, another shortcut here is, this is a little long. We can do some shortcut, but in order to do the shortcuts, you have to see it. Okay, you have to notice something. So it requires some experience. For example, here, how about doing this? So make it 8 pi, and this will be tangent minus. So since it's the multiple of pi, it's okay. It will be equal to the same thing here, and which is equal to, when you do the calculation, it's minus pi over 4, and then tangent is an odd function, so you can take this minus out, so it will be tangent pi over 4, and it is minus tangent 45 degrees, and this will be minus 1. You can also do this, but it requires some experience to see the things, Now let's look at here. Okay, here are the solutions. These are the ones I told you. Okay, this is the shortcut here, adding 2 pi, and here you can subtract 8 pi and get minus pi over 4. This is one way. Okay, let's do the try and checks here. Okay, let's evaluate the following. Okay, cosine 4 pi. Okay, the period of cosine is 2 pi, right? So I can add or subtract the multiples of 2 pi. So multiple means mudaf, I guess. I think it was mudaf, something like this. So 4 pi, I can remove 4 pi from here, so it will be 0, cosine 0. Okay, what is cosine 0? Okay, you do the unit circle here, it will be 1, 0. This is cosine 0, and this is sine 0. I mean, you can use the unit circle, and when you take a point, this is corresponding to 0 angle. So this point is cosine 0 is 1 then. And this one here is tangent minus 7 pi over 4. Okay, to get this one, we can use the the shortcut here, adding 2 pi. and this will give us tangent pi over 4. The period of tangent here is pi, and adding to pi, okay, it will work. So this thing is equal to tangent pi over 4, which is tangent 45 degrees, and this is 1. And for 31 pi over 4, I can do the same thing. The period of sine is 2 pi, and I can add or subtract the multiples of 2 pi, and I will go with here 8 pi. I will subtract 8 pi. This is a multiple of 2 pi. Then it will be sine minus pi over 4, and this is minus sine pi over 4. This is 45 degrees, so it will end up, you will end up with minus 1 over square root 2. Okay, these algebraic manipulations and these operations, you will get used to them by doing exercises. Maybe it's not clear at the first sight. It's not easy to find a way to do it. But if you have some experience, then it's after some experience, it's not hard to see the things, the shortcuts. Now we will see how to find the periods of different transformations of trigonometric functions. Now, the functions that are formed by applying the basic transformations to trigonometric functions are also periodic. So here it gives the relations here. So assume it's a function has a period p, then adding plus c here, you shift this function to the left or to the right depending on c. You make a new function from it, but its period is again same, or shifting it up or down, or adding c to the function. Okay, it will not change the period. And here multiplying the function with another constant, it will not change the period. No change here. But if you change the input here to ax, then the period changes to p over the absolute value of a. So now by adding all these, we can say if f is a periodic function with p and a, b, c are real numbers, then the period of a times f of bx plus c is p over the absolute value of b. So here multiplying the function doesn't change the period, and we know adding c to x, it doesn't change anything, but multiplying x with b, it makes the function's period divided by b. Okay, we will use that in the following example. Now find the period of each of the following functions. Now the first thing is you have to pay attention to cosine. So what's the period of cosine? The period of cosine is 2 pi. Now, the rule says the period of this function will be 2 pi over the absolute value of 10, which is 10. So the new period will be pi over 5. So the period of this will be period of f1 will be this. Okay, let's see them. And for the others, we can tell them right away. Here sine, it has a period, it's 2 pi, and here what is the coefficient of x inside 2 pi? So the function has the period of f sub 2x is 2 pi. So I'm writing from here divided by this 2 pi here, but it's absolute value. Sometimes there's negative, so you have to put the absolute value there, but here not very important, it's just 1. And let's do the other one. what is the period of tangent here? Tangent's period is pi. And what is the coefficient of x? It's minus 2 over 3. So the period of f sub 3x of x is pi, that comes from here, divided by the absolute value of minus 2 over 3. And this means pi over 2 over 3, and which is 3 pi over 2. So let's see how it is done in this slide. Okay, this is exactly what I'm telling you. And the same thing here. The period is 2 pi and b is 2 pi here, and then you divide them. And the same thing, tangent has a period pi, and then you divide, sorry, this period is pi, then divided by the absolute value of b, which is the coefficient of x inside the function. Now we have, try and check. Okay, you can do the periods here. They're easy. I don't want to do them. I will stop the video and try to do it by yourself. Now I will write the answers here. The period of this will be equal to 2 pi over 2, which is pi, sorry. And for this one, the period of f of 2 is pi over 2 pi, so it will be 1 over 2. So you can check it.